There are lots of ways to write equations of lines. So which one do you use? Well, it depends. It depends on the information you know about the line or the information you want to know about the line. So let's play a little game. I want you to think about a line and give me some information about it. Okay, it has a slope of 3. Now I need a little more information because there's lots of lines that have a slope of 3. Ah, the y-intercept is 2. Perfect! You've given me just enough information to write the equation of your line in slope-intercept form. Slope-intercept form looks like this, y equals mx plus b. In that equation, the m represents the slope of the line, and the b represents the y-intercept of the line. So since you already gave me the slope and y-intercept of your line, I know that its equation is y equals 3x plus 2. Now I know you might be a little skeptical that it's as easy as that. So let's figure out if my equation really is the equation of your line. And we'll do that by figuring out some points that are on my line. And we'll use that to graph my line and see if it's the same as your line. If x is 0, 3 times 0 is 0, plus 2 is 2. If x is 1, 3 times 1 is 3, plus 2 is 5. And if x is 2, 3 times 2 is 6, plus 2 is 8. So we've got 3 points that are on my line. We'll go ahead and graph those points, and we'll see what my line looks like. So we have 0, 2, 1, 5, and 2, 8. This is my line. That's the graph of y equals 3x plus 2. Now the question is that your line too? So let's see. Your line had a y-intercept of 2. Yep, mine does too. And your line had a slope of 3. Well, let's figure out what the slope of my line is. If I go up 3 and over 1, I find 2 points on my line, and that means the slope of my line is 3 over 1, which is 3. Perfect, that's your slope too. So you can see that my line, y equals 3x plus 2, is the same as your line, a line that has a slope of 3 and a y-intercept of 2. Okay, remember, slope-intercept form is y equals mx plus b, m is the slope, b is the y-intercept. Go, give me information about your line. Okay, you did not give me the slope or y-intercept this time, did you? You're going to make this a little bit trickier. Your line passes through the points 2, 6, and 3, 4. Tell you what, I can still figure out the slope and y-intercept of your line. Here's how I'm going to do it. I know that slope is the change in the y-coordinates of 2 points on your line divided by the change in the x-coordinates. So let's see, the y-coordinates change from 6 to 4, that's decreasing by 2, and from 2 to 3, that's increasing by 1. So the slope of your line is negative 2 over 1, or negative 2. Perfect, I've got half the information I need. We do know that the equation of your line is y equals negative 2x plus b, and you gave me 2 points on your line. So let me pick one of them out. I'll pick 2, 6 out. That means when x is 2 and y is 6, I can make the equation of the line a true statement. So let's go ahead and put 2 in for x and 6 in for y and see what we get for b. Ah, b is 10. Now I know your y-intercept. So the equation of your line is y equals negative 2x plus 10. Now I don't expect you to just take this for face value that I really did find the equation of your line. So let's see if your line and my line make sense together. Your line passes through 2, 6 and 3, 4. So if we graph your line, we can see that it looks like this. My line, which I'm claiming is the same as your line, has an equation of y equals negative 2x plus 10. That means that in my line, the y-intercept is 10, matches up with your graph, And in my line, the slope is -2. Let's see if that's what your slope is. Go down 2 over 1. Yep, your slope is -2 as well. Our slopes match, our y-intercepts match, so that means y equals -2x plus 10 really is the equation of the line that passes through 2, 6 and 3, 4. So slope-intercept form is pretty useful, isn't it? If we know the slope of the line and the y-intercept of the line, we can write the equation of the line, or we can even use slope-intercept form to find the slope and y-intercept of the line. And we also saw that if we have 2 points on the line, we can still write the equation of the line in slope-intercept form because we can determine the slope and the y-intercept from those 2 points. Does that make sense? Okay, great. Now, let's talk about something else. There's actually 2 special cases that we need to think about when we're thinking of slope-intercept form. And that is, first of all, horizontal lines. Now, horizontal lines have a slope of 0. And in terms of our slope-intercept equation, that doesn't really change anything except if the slope of the line is 0, then the equation of a horizontal line will no longer have an x term in it. It will just be y equals b, where b is the y-intercept. Here's an example. This is a horizontal line that goes through 7 on the y-axis. Its equation is y equals 7. Every point on that line has the same y-coordinate, which is 7. The other kind of line we need to think about is a vertical line. Vertical lines have an undefined slope, and that makes slope-intercept form a little tricky because we don't actually have a number to substitute for the m. Vertical lines have an equation of x equals some constant, and that constant is the same as the x-intercept of the line. Here's a vertical line. It goes through 3 on the x-axis, and its equation is x equals 3. Every point on that line has the same x-coordinate, which is the number 3. So now you know something about the equations of horizontal and vertical lines as well.